Hello everyone. In this video, I will talk about some basic derivative rules for polynomials. These rules are derived from the delta method or from the definition of the derivative, but these rules shorten the process of taking the derivative considerably. So let's start with, first we're going to talk about a constant polynomial. So the derivative of a constant is 0. So there are a few ways you can think about this. If we have a function y is equal to c or fx equal to c, so it means we have a straight line. And what is the slope of this straight line? So slope of a horizontal line, in this case horizontal line, so slope of a horizontal line is 0, because we know that slope is rise over run. So in this case there is no rise between any 2 points, so the slope of this line is 0. So graphically we can see that the slope is 0 means the derivative of a constant function is 0. So other way of thinking about this formula is, so where does this come from? We can talk about our delta method. So if I try to find limit h approaches to 0, f of x plus h minus fx over h, and I plug in the value of the function here. So since function is c and it is independent of x, so in the next step you will get c minus c over h. So limit h approaches to 0, 0 over h is just 0. So that's why we had this very important result that slope of any constant is 0, or the derivative of any constant is 0. So all the formulas that we are going to discuss today, they are derived from the delta method of derivatives. So I'm not going to derive every formula, but it's good to know that where they come from. So thus we learned that derivative of a constant is 0. So for example, if you have a function y is equal to 5, so this implies, so if you take the derivative with respect to x, so derivative of this function would be 0. So derivative of any constant is 0. Next, we are going to talk about derivative of a power function. A power function is a function, so where we have nth power of x. So in this case, so if we want to find the derivative of x raised to power n, so the formula is, so you bring the power down, so power multiplied by x raised to power n minus 1. So bring the power down and reduce the power by 1. Thus, derivative of x raised to power n is equal to exponent n times x to the power n minus 1. So you bring the power down and you reduce the power by 1. Let's discuss few examples using this rule. So for example, let's say we have this function y is equal to x raised to power 5, and you want to figure out the derivative. So taking derivative with respect to x on both sides, so du over dx of y is equal to derivative of x raised to power 5. And then we know that the derivative is equal to, so bring the power down and decrease the power by 1. So earlier we had 5, so now we're going to do 5 minus 1. So we get 5x raised to power 4. Again, in the next one, so let's say we have y is equal to x. So if we want to take the derivative of this function, so taking derivative on both sides with respect to x, so you can think this as x raised to power 1, and you will notice that we have, So bring the power down, reduce the power by 1. So x raised to power 0, which is just 1. Or in other words, you can think of this as dy over dx is equal to dx over dx. And then you notice that these differentials cancel each other and we get equal to 1. So either way, either you use the power rule or you just do the cancelling, you get 1. So derivative of x is 1. Let's try another case when we have a negative exponent. So in this case, we can write this as x raised to power negative 2. So again, in this case, if you want to take the derivative on both sides, so derivative of x raised to power negative 2, so that would be equal to negative 2 x raised to power, so decrease the power by 1. And we get negative 2 x raised to power minus 3, which indeed is negative 2 over x cubed. So always try to give your answer in terms of positive exponents in the end. So far we have discussed the cases when we have a positive exponent or when the exponent is 1 or when the exponent is negative. What if we have a fractional exponent or an exponent which is in the decimal form? In this case, so taking derivative on both sides, so we have 0.4 as our exponent. We bring the exponent down and decrease exponent by 1. And we see that we get 0.4x raised to power negative 0.6. Which in turn is, so 0.4 is 2 over 5. And x raised to power negative 0.6 is in the denominator, it becomes x raised to power positive 0.6. Thus, for every kind of power functions, so as long as your power is a real number, you can apply the power rule, which is bring the power down and reduce the power by 1. So multiply these two expressions together. Next, we are going to do a bit of extension of power rule. So if we have constant times a power function, so derivative of constant times a power is equal to, so you can write this as, so you can bring the constant outside and you can take the derivative of the variable part. So in this case, it would be c, and this we have already done in the previous part. So bring the power down, decrease the power by 1. So thus we get c and x raised to power n minus 1. This rule is also called constant factor rule because the constant c is multiplied with the function. So c is a factor. Let's try a few examples. So first we have y is equal to 3x squared. So taking the derivative on both sides. So 3 is a constant factor here. So we can bring 3 out and take the derivative of x squared. And in order to find the derivative of x squared, we use our power rule. So bring the power down and decrease the power by 1. So in this case, we get 6x. So one thing that I would like to point out that sometimes people confuse derivative of a constant times a function with the derivative of a constant that's alone. So don't make that mistake. So y is equal to 3x squared, so dy over dx. And sometimes people think, oh, so derivative of a constant times derivative of x squared, and then try to write that this is 0, and then it doesn't matter what you have, so you get 0, which is not the case. So this is wrong. So don't mix the derivative of a constant times a function versus the constant alone. So thus don't mix the derivative of a function times constant with the derivative of a constant that stands alone, because derivative of a constant that is alone is 0. So next we have y is equal to 5 over x squared. So if you want to find the derivative of this function, so derivative of, again we have, I can rewrite this function as 5x raised to power negative 2. So 5 is the constant, it can come out, and then derivative of x raised to power negative 2. So bring the negative 2 power down and then reduce the power by 1. So which gives us, so negative 10 x raised to power negative 3, or in other words, negative 10 over x cubed. So that is our required derivative. Next, we're going to discuss the derivative of a sum. So it means, so if you have sum of few functions or few polynomials or few terms in a polynomial, so in that case, let's say we have u, v, and w, which are three functions of x. So derivative of sum of the functions is equal to sum of the derivatives of individual functions. So we're going to use this result to solve these two examples. Let's first try the first one. So dy over dx in this case would be, so you can take the derivative of individual terms. So derivative of x cubed plus derivative of 2x minus derivative of pi cubed. So in this case, we notice that derivative of x cubed, which is a power function, so bring the power down, reduce the power by 1. Similarly, the derivative of 2x, so 2 is just a factor, so it's in the product, so you bring it out, and then derivative of x is 1, so you just get 2. And then we have derivative of pi cubed. So pi is a constant, pi cube is a constant, so the derivative should be 0. So overall we get 3x squared plus 2. So that is our answer. So make sure you don't mix this with the power rule. So this is a constant because it's a pi cube. And here we use the power rule because this is x cube. We have the variable here. For the next one, again, we take the derivative with respect to x on both sides, and we get derivative is derivative of individual term. So for first one, we get negative 4x squared plus derivative of 1 over x squared, and I'm going to rewrite that as x raised to power negative 2 and derivative of 4. And we notice that, so here negative 4 is in the product, so it comes out, and derivative of x squared is 2x. Similarly, x raised to power negative 2, so power down, decrease the power by 1. And lastly, we have derivative of only negative 4, which is stand alone. So derivative of a constant is 0. Negative 8x minus 2 over x cubed as our answer. These are the 4 basic rules for derivatives. So remember, derivative of a constant is 0. Derivative of a power function is bring the power down, reduce the power by 1. And then derivative of sum is equal to sum of the derivatives. So just a little bit overview of what we know about the function and derivative so far. So function, we write the original function y or fx. So derivative notation is dy over dx or f prime x. So function gives us the value of a function for each x value. Derivative gives us the slope of the function for each x value. And this is also a function of x. They both are variable. But if you want the slope at a particular point, you can plug in the value of x and you can find the slope at that point. Similarly, if you want the value of a function at a particular point, you can just evaluate the function at that x value. Thanks for watching. So make sure to subscribe to watch any future videos. I hope that you enjoyed this video.